Now we have the honor to listen to somebody who actually spent time in outer space, somebody who did human spaceflight, Léopold Eyharts. He was on the mission to the Russian Mir space in 1998. And then again, he was in outer space in 2008 and returned to Earth with Space Shuttle Flight STS-123 on March 27th. He flew to the ISS, the International Space Station, with Space Shuttle Atlantis and performed various experiments in the area of medical research, neuroscience, biology, all things that were mentioned at the very beginning. Why do we actually go out there and what we want from it?
All right, ladies and gentlemen, good evening. Very pleased to be here, and I would like to thank our host for inviting me today and giving me my first opportunity to come to Vienna, even if I'm a European citizen, but I'm very pleased to be here tonight. I wish I could tell you that I landed on the moon, but that's not the case, and you probably wouldn't believe me. I orbited the Earth, as most of my colleagues, astronauts, today, twice. Actually, I had 2 flights, but during my 2 flights, I had the chance to fly on 4 different vehicles. As was mentioned before, I flew first in the Mir space station, and I went up and down to the Mir space station, to and from the Mir space station in a Soyuz spacecraft. And last year I flew in the International Space Station and went up and down in the shuttle. So that's why I was asked today to make a presentation of a comparison of the 2 stations, the Mir space station and the International Space Station, from an architecture standpoint. Excuse me. Yeah, I will start my presentation. Yeah, I will take 30 seconds to do it in a few minutes. The interesting thing in space is that there is no real artistic approach for designing space infrastructure, as we call it. Everything is always driven by technical requirement. So we sometimes end up with an artistic view of the space objects, but it's just by chance. So what I'm going to show you today is only technical facts, and I leave it up, of course, to you to see the artistic part of it. So I will just take a few seconds to start this presentation. I'm not an Apple guy, so I will need some help, I guess.
This? Yeah.
And I just push it. Okay. All right, and I will use my pointer. It's working. Should I try again? Here we go. All right. So I will start with the Mir space station. I had to dig into my memory and my archives to find some pictures, because the Mir space station is part of history. And actually, I also use the internet, as you can see, with Encyclopedia Britannica. But that was a nice view of the station, of the Mir space station. So what you see here is a space object, so the Mir space station, of course. And it's hard to see here, let's say, the type, the configuration of the construction. And actually, this is what I would call a star type of construction. The center of the star is here, in this docking port, as we call it. And this port is part of these long modules that you see here. All the other modules are connected to this port, and there are also some docking ports in other parts, as we will see that later. What you can see also is that there are solar panels in all the vehicles, and this configuration is actually not optimal for bringing power to the station, but this is driven by the Russian approach for building space stations. And the interesting thing here in the Mir space station is that no man is involved in the construction of the station. Of course, man is involved in the operations, and there are vehicles bringing men to and back from the station. But the construction is made by automatically. I mean, the vehicles are launched by heavy Russian launchers, the Proton launcher, which will, and every module has its own system for making rendezvous and docking to the station automatically. So that's the Russian approach, and that explains why all the modules also have solar panels, because during the autonomous flight to the station, where they will need power, of course. And that also explains this configuration, the star configuration, because all the modules dock to the same spot. We can say that. And that also, of course, will minimize the amount of equipment needed for rendezvous and docking. The modules, the Russian modules, are often based on old modules which were developed before by for the civilian stations, civilian station or military stations. So most of them are the sub-modules of each modules. We can say that are based on the old vehicles or older vehicles, and we ended up with different type of modules here. The main one is the one I just showed before, which is the let's say core of the station. All the other modules were in the beginning scientific modules, and then they turned out to be not only scientific modules but also system and storage modules. Storage is a big issue with the space stations. So the main longitudinal axis is here, and the star where all the modules are docked is here. And this is an actual picture. I'm sorry, this one is probably not very visible here, but this is an actual picture from different standpoint. It shows how the station looked like at the end of the 90s and after the end of its assembly. So talking about assembly, the assembly took about 10 years, started in 1986. The life duration of the station is, let's say, unknown because it was deorbited in 2001, but it was definitely aging, and there was more and more work involved for the crew to maintain the station. The last module added was a pre-rotor module, and it was added in 1996, if I remember well, and the pre-rotor module should be here. One of them was lost in the 1997. That's the so-called SPECTRE module. It was lost because of a collision with one of the cargo vehicle, a Progress vehicle, and there was pressurization of the station. However, the module was isolated by the crew before the station was completely depressurized, and the next crew was able to fix it. So to restore, because what was lost, you see there are a lot of solar panels here, but about 50% of the power source of the station was lost. And I remember this fact very well because it was the crew I was launching with who went to repair it. So my flight was delayed by 6 months because there was not enough power in the station for performing my space experiments.